Hello everyone. My name is Vivek. I am a software developer. I make videos about containers, Kubernetes, Go as a programming language, distributed systems, and sometimes about software engineering in general. So, if you have been liking the kinds of videos that I make, you should consider subscribing to the channel and you should follow me on Twitter as well. In this particular video, we are going to continue writing the operator that we have been writing in some of the previous videos. So we started writing this operator that is going to provision a DigitalOcean cluster as soon as a cluster resource is created. So we introduced a custom resource named cluster with K, so Kluster, and as soon as a cluster resource is created on let's say on a specific Kubernetes cluster, respective DigitalOcean cluster, respective Kubernetes cluster in DigitalOcean would be created. So we were already able to do a lot of things. We have generated CRDs, we have generated all the code scaffolding, for example, informers, listers, client set, and deep copy functions. And we were also able to implement a part where as soon as a particular cluster resource is created, a Kubernetes cluster on DigitalOcean would be provisioned automatically, and we were able to demo that in the last video itself. So if you have not gone through that, I would I would provide the link. You should watch that as well. So in this particular video, we are going to write the other part where we are going to talk about sub resources in detail and what exactly are sub resources, why do we use them, and things like that. And we are also going to look into how we can leverage sub resources in our use case. So before doing that, there is this one thing that I would like to highlight is when we wrote in previous video, we did a mistake. So when we initialized node pool create request, even though we were taking node pool count, name, and size, when we passed that to this Kubernetes cluster create request, we specified size as the value of name as well. So let's just go ahead and try to correct that. So yeah, this is one mistake that we did in last video. Now let's go ahead and try to very briefly discuss about what exactly are sub resources and why would we want to use them. So if we take an example of our use case, we have introduced a particular cluster custom resource, and that is the reason we are able to create this particular resource, this particular object on Kubernetes cluster. Now if you see, for the field spec, we specify all the configuration for this cluster resource. So for example, these are all the configurations using which our Kubernetes cluster should be set up or provisioned. Or in other words, we can say that as the value of spec field, we specify all the custom configurations, we specify all the specifications for the instance that we are going to create. So that goes inside spec, but there are chances that there are some things that the operator that is running would want to add into this manifest or into this object. So let's take an example. So we have specified all the required things under spec, but as soon as DigitalOcean we call DigitalOcean API to create the Kubernetes cluster, we do get the cluster ID, and it would be really helpful if this controller can write this cluster ID to the cluster instance that was created. So if we apply this particular manifest, we know that a cluster instance is going to get created, and as I said, it would be really helpful if the controller can specify, or if the controller can put that cluster ID somewhere in that created cluster instance. So there are some other examples as well. So this is one use case, so that users who are applying this particular cluster manifest, they can get the manifest again using -o YAML flag, and they would be able to figure out cluster ID of the Kubernetes cluster that was created on DigitalOcean. The other use case would be, for example, let's say we know that creation of cluster on DigitalOcean is going to take some time. So for example, it might take 4, 5, 6, or even 10 minutes. So as soon as we call the DigitalOcean API, we can specify that, or this controller that we are writing, this controller can specify that, okay, the status of that cluster instance is, let's say, creating, and once that cluster has been created, that status would be changed to completed or created. So again, users who are applying or who are creating this particular instance can describe or can get this instance or can get this cluster resource using -o YAML flag, and they would be able to see those fields that have been set by controller or operator. And those fields are, as I said, maybe cluster ID, or for example, what is the status of the things that are going on behind the scene. The other very useful case is, so if we talk again about the same use case that we are writing here, so for example, Kubernetes cluster has been created on DigitalOcean, but there should be a way to connect to that Kubernetes cluster. And in that case, it would really be useful if we can set kubeconfig file for the cluster that has been created as part of this resource. And these are all the use cases because of which we would want to use status field. So status is the field where controller usually writes all these things that would be useful for the users for future reference. So for example, if we talk about typical scenarios, so we specify type meta, or let's say API version, kind, metadata, and then we specify spec. And as we discussed, apart from spec, we can also have status field, and status is where controller or operator can specify all these things that we talked about. So for example, cluster ID, we can also have progress, and progress we can have value of progress is going to be a string, or enum, it can either be created or completed, something like that. And eventually we can also have, let's say, kubeconfig. So after controller has updated these fields, users can get this particular resource using -o YAML flag, and they would be able to see these things, which would be pretty ideal. They can figure out cluster ID, they can figure out kubeconfig, and once they have kubeconfig, they can access that Kubernetes cluster. So this is the use case of status. Now let's go ahead and talk about why do we have sub-resources. What exactly are sub-resources? So now, if you see here, we know why should we use, or why do we want to use statuses. And we also know that the things that are inside spec, all the things that are inside spec should be updated by the user who is creating this particular resource. So if we talk about cluster 1, inside cluster 1, this entire thing should be ideally updated by the user who is going to create this manifest. So he can specify name, reason, version, node pools, etc. So spec field ideally should be updated by the users. But if we talk about status field, if you see here, we have always said that these things are going to be updated by the operator or by the controller itself. So there is separation between spec and status. Spec can only be updated by the user, and status can only be updated by, or status should only be updated by the controller. Now to enable this, what happens is, to make this particular thing more, I would say, fine grained so that we can specify separate roles for this spec field and status field. Kubernetes also provides this concept of sub resources. So for example, if we talk about, let's say, again, let's say pod is a resource, we know that pod is a resource, and for pods we have logs as sub resource. So we can query logs sub resource for pods to actually get logs for a specific pod. I'm talking about some of the examples of sub resources that are already there for Kubernetes native resources. Similarly, we have some other sub resources, for example exec for pods. So if we make a request to exec sub resource for pod, we are going to get a terminal for pod, so etc. These are some of the examples of already available sub resources. Now we know that almost every resource gets mapped to a particular endpoint in Kubernetes API server. So for example, if we talk about deployments, the endpoint is going to be, for example, APIs apps v1 deployments, and then namespace and then deployments. So similarly, we are also going to have things for pods. So let's say pods and then pod name, and then yeah. So what I'm trying to say is every resource is actually mapped to an endpoint in Kubernetes API server. Similarly, if we talk about sub resources, so for example, if we talk about logs sub resources, in that case, this is also going to map to a particular endpoint. So for example, if we talk about logs sub resources, this is how that endpoint is going to look like. Let me just very quickly confirm that this is correct. So yeah, v1 namespace pods pod name and logs. Okay, so now we know how the endpoint for a sub resource looks like. So now the thing is, let's get back to what we were talking about. So spec should only be this particular field should only be updated by users. This particular field, these fields or status field should only be updated by controllers. And to enable this, we have sub resources. So as soon as we specify this field to be sub resources, we know that this particular field or status of this resource is going to be available as an endpoint. And in that case, when we create a role, we can specify that this particular role is only allowed to edit statuses and not the spec. So for example, if we create a role, let's say role test, and this is the role using which this particular operator is going to run. So when we specify resource, we are not going to specify cluster resource, but we are going to say this particular role is only allowed to edit status sub resource for this particular resource. So if you see here, if our operator is running using this particular role, our operator will not be able to update or edit spec field of the Kubernetes object. So I hope this made sense. Maybe I will try to summarize this at the very end. Now let's just go ahead and try to achieve this. So for example, if we have a cluster ID here, let's first of all go ahead and try to add the status field in our cluster type. So status, and this is going to be of type cluster status, and here we go. All right, so now we are going to have status as we discussed cluster ID and progress. We are not going to implement kubeconfig for now, but maybe we are going to implement kubeconfig later. In this video, we are just going to talk about cluster ID and progress. So let's have cluster ID. This would be of type string, and we are also going to have JSON tag. So cluster ID, and we should also have progress string, and then we are also going to have maybe these data types. So this is going to be, this can be another type to implement enums, and this can also be maybe slice, I think, of bytes, but for now, just to show you, I'm going to use string itself. Okay, so now things look good. The other thing that I wanted to talk about is, okay, so when we want to specify this particular thing or this particular field as sub-resource, we can specify that, we will have to specify that in CRD as well. So if we talk about, okay, so we know that this is our CRD. We are not specifying sub-resource anywhere, but we will have to specify sub-resource in CRD as well. And to do that, what we can do is we can either add the CRD manually in this CRD. Sorry, we can either add sub-resource field in this CRD, or what we can do is we can have a go tag, build tag again, like we have these tags. We talked about these tags in one of the previous videos. So if you are not sure about this, maybe you can refer that as well. So now we'll have to specify that this particular field is a sub-resource, so that we can run controller gen again, and CRD would be generated again with the updated things. So for example, updated sub-resource. So to do that, I think I remember builder, remember the syntax, and we want to specify sub-resource, and this is going to be status. So this should be something like it. Let me refer the notes that I have. So builder, sub-resource, and sub-resource is going to be status. Now let's just go ahead and try to run controller gen again, and we would see that sub-resource field would be added to this CRD. So let's just go ahead and try to run controller gen. Okay, and if we go to, here we go. So we now have sub-resources field here, and it simply says that sub-resources is status, and we can also see that this status field has been added in the definition. So yeah, once we have done that, let's just go ahead and try to create the CRD now. So create -f manifests, and okay, we have CRD created now. And now let's just go ahead, and if you see here, we have cluster ID. Let's call a method updateStatus. So func and we have to pass the cluster ID. So cluster ID, and we will also have to pass the progress. So let's just pass it as of now to be creating, and this is going to expect ID and progress to be string, and Now what we are going to do is we are going to call update status on this cluster resource. So for example, if I go ahead and try to create a cluster resource now, if I go ahead and try to create this cluster resource, we are going to call update status on this cluster resource. But if we, for example, go ahead and try to see if we have update status method generated, so c dot client dot, so if you say here we have create update, and this code base was generated by us. I explained this in details in one of the previous videos already. So we have list, create, update, etc., but we still don't have update status. But we should have update status, because now this operator wants to update the status of the cluster resource. So to do that, what we are going to do is we are going to generate the code again, and since we have specified this status field here, now that interface is going to have this interface that we have is going to have update status method generated. So let's go ahead and try to do that. So and this particular command is going to generate all the scaffolding again. If you don't know what exactly this thing is going to do, I highly recommend checking out some of the previous videos from this playlist. There I explained these things in a lot detail. So as soon as this is generated or this is completed, we should get update status method on cluster interface. So let's just go ahead, and here we go, update status. So now what we are going to do is we are going to say c dot client dot, and this expects a namespace dot clusters expects and this update status is also going to expect the cluster for which we want to update the status. So we should have a cluster here, so let's pass cluster as well. Okay, and we are going to say cluster dot status dot cluster id equals to id, cluster dot status dot progress equals to progress, and then we are going to update the status. We have to get a meta v1 for the options. Okay, and here we go. This expects namespace, so we are going to say cluster dot metadata or namespace directly, and update status returns cluster and error. So underscore colon error, and let's just return error. So we are going to log error percentage s updating status of the cluster percentage s, and error is going to be error and cluster. Let's display cluster name. So cluster dot name. I'm just logging it here, but there are some other things that you can do. For example, we are going to look into those things in further videos, but you can maybe retry the operation, or whatever you want to. So let's just go ahead and try to run this. But before that, I want to talk about another thing. So another things. So for example, or maybe let's just go ahead and try to run this. So go build, and CRD is already created. We are going to create the CR. If I show you my DigitalOcean dashboard, we don't have any Kubernetes cluster created here. So as soon as we create the cluster resource here, a Kubernetes cluster resource should be created on DigitalOcean. So create -f manifests and cluster1.yaml. This is going to be created in default namespace, and let's hit enter. Okay, so yeah, it simply says secrets do secret not found while creating the cluster. And the reason is, if you remember from the previous videos, we try to figure out DigitalOcean token from the secret that is mentioned in the cluster instance. So we are specifying do secret to be this. So and so it simply means that DigitalOcean token is stored in this particular namespace on, or in this particular secret, but we don't have any secret with that name. So let's go ahead and try to create that secret. So yeah, I think this is good. I just have changed the token. So maybe that is one thing that we will have to. Okay, so do secret has been created. Okay, now let's go ahead and create the cluster again. So create -f manifest cluster1, and let's see if things work as expected. So here we go. We have cluster ID. So it simply means that cluster should be created on DigitalOcean. I mean, it should be in progress, but after some time, yeah. So here we go. Cluster 0, and this is one thing, this is the thing that I wanted to, or that we tried to do in this particular video. If we get the cluster that we just created, cluster instance named cluster 0, and if we say -o YAML, we should be able to see status in -o YAML. So here we go. So inside status, we see that cluster ID is this, and we see progress to be creating. Now in production level code, there would be a daemon, a process running that is going to, and maybe we are going to implement that as well, and that is going to update this progress to be created as soon as this cluster is created on DigitalOcean. So this is exactly what I wanted to show you. This is exactly what I wanted to implement in this particular video. Now, another thing that I wanted to talk about is, if we, for example, get clusters from all the namespaces, we just see namespace and name and is, but it would really be helpful if we can show the cluster ID as well. So this is what we are going to do now, and that is I would say very easy. That's not a big task. So to do that, what we are going to do is we are going to see how can we specify how we can specify additional printer column in types.go. So again, when we specify types.go, like we specified subresource, we can also very easily specify which particular field is going to be uh, should be shown as additional columns as the output of kubectl get. So let's just go ahead and try to do that. So additional printer column, yeah, here we go. So if we see here, so eventually we can directly go ahead and try to specify additional printer column in the CRD itself. So for example, in this particular CRD, we can just go ahead and try to add the additional printer column, and we can very easily do that. But just to make that thing easier, or just to leverage the controller gen that we are using to generate this CRD, what we can do is we can add this tag in types.go, and when we run controller gen is going to update the CRD with additional printer column. So that is what we are going to do in this particular section. So for example, if we talk about any example here, so let's say types.go, and print column name is going to be cluster ID, type is going to be string, and JSON path is going to be status dot cluster ID. And similarly, we also want to have progress. So name of the column is going to be progress, type is going to be string, and progress value is going to be status dot progress. Now let's just go ahead and try to run the controller gen again. So controller gen, and now we should be able to see additional printer columns as well. So here we go. So it's not actually necessary to have this particular tag in types.go. As I said, we could have directly gone to the CRD and added these additional printer columns, but since we are using controller gen to generate the CRDs, what we did is we added this tag in types.go, and controller gen already took care of adding this to CRD. Now let's go ahead and try to update the CRD. So apply -f manifests, and here we go. So CRD has been configured. Now if I get, for example, if I try to create another Kubernetes cluster, so create -f and manifests cluster2. So cluster 2 has also been created, and if I get cluster again, here we go. So if you see here, now we see name, cluster ID, and progress. So these are two additional columns that we have specified in our CRD. So yeah, this is what I wanted to talk about. The other thing that I wanted to highlight very briefly is we know that for versions, we can obviously specify more than one versions for a particular CR. So for example, if we want our cluster kind to be part of more than two versions, for example v1 beta 1 and v1, in that case we can obviously specify two versions, but we have just specified v1 alpha 1 as of now, I think. Here we go. So status resource can also be specified for different versions. So for example, in one version we can have status resource, and in another version we cannot have, or we may not have status sub resource. So yeah, this is what I wanted to talk about in this particular video. If we once we try to install this entire thing on on Kubernetes cluster, then we are going to actually look into these things in much more detail, and then this is going to make much more sense. If I try to maybe very briefly summarize this entire thing, we specify, or users specify the configuration, the things under spec, and then operator or controller updates or adds something under status. But to make sure that that controller is not able to update spec, we can specify or Kubernetes helps us with sub-resources, so that we can create a role and we can allow controller to just interact or just update the sub-resources instead giving it privilege to update the entire resource. So yeah, I hope this makes sense. If you have any question about this, don't hesitate to ask in the comments. Uh, and yeah, thank you so much for watching. If you think this is going to be helpful for your colleagues, friends, maybe share it with them. I'll see you in the next one. Thank you so much.